Imagine a tremendous gathering played by a never-ending number of planets. Stars and moons all playing together superbly. At any rate, there is one explicit fragment of this ensemble that has shocked space specialists for a seriously significant time frame: exoplanets. Exoplanets are ordinary planets that exist outside our planetary system, hid away somewhere deep in the Milky Way. You might be surprised to find that among the gigantic number of galactic objects, there are exoplanets, so like Earth, so tantalizingly similar, yet confusing that they might be our divine twin. We enter the charming space of Proxima B, found just 4.2 light-years away. The James Webb Space Telescope is disturbing our journey for an understanding of these divine secrets. Imagine a second when your mind adventures across the huge vastness of our reality, the Milky Way, which is home to more than a quadrillion exoplanets. That's a number with 15 zeros. To place this number in relation to something tangible, if each of these exoplanets were the size of a grain of sand, we wouldn't simply fill the Grand Canyon, we would have enough to make another landmark on Earth. A Grand Canyon 2.0. That would extend for a huge distance. It is generally surprising that around 20% of these glorious bodies have been designated Earth-like, as far as geology and atmospheric structure. That means there is a 1 in 5 chance of seeing a twin of our planet, and the story doesn't end there. Close by these quadrillion exoplanets, there might be another planet. There are also quadrillions of moon's rough satellites, like our moon trapped in a gravitational dance with their parent planets. If you were to wonder about tracking down another spacecraft that is home to life or could be the universe, offers a flood of chances. Now that we have spread out the enormous amount of material, it's time to introduce the master-skilled worker prepared to paint its complex nuances. The James Webb Space Telescope, this heavenly Sherlock Holmes, with its amplified central focal point, displaced by customizable central focuses, beats even the most advanced optical instruments. We're not discussing any ordinary lens. Its 6.5-meter primary mirror is 2.7 times greater than Hubble's. It can separate even the finest level of detail in the smallest blaze of a star billions of light-years away, and then investigate the particulars of orbiting planets. What makes the James Webb Telescope revolutionary isn't simply its seeing power, but also its highly advanced technology, including sensors and spectrographs. These tools can do considerably more than simply observe. They are able to evaluate and decode the remarkable light signatures emitted or reflected by celestial objects to decipher their atmospheric conditions, density, and even mass. Acting as a space researcher, Webb can determine whether a planet has water, organic compounds, or even oxygen. The James Webb Space Telescope has the ability to answer these inquiries, lifting it from a simple observer to a scientific genius. It's not only a slight improvement over its predecessor, Hubble, it's more like a quantum leap. If Hubble's revelations stunned you, get ready for a genuine celebration of radiant discoveries, just as we extend our look across the complex landscape of the universe. It's worth zeroing in on one specific star in the divine show, Proxima B. Since its discovery in 2016. This baffling planet has stood out like a Shakespearean legend, brimming with unpredictability and problems astonishing stargazers and anthropologists alike. What's the deal with all the fuss? First of all, Proxima B is basically in our galactic neighborhood, just 4.2 light-years from Earth. To put it in context, if you could beat the universal limit of speed and travel at the speed of light, you would arrive in just over 4 years, about the same amount of time it takes for your favorite show to fall into reruns. But let's dive deeper into why this class is so critical. We're examining a universe that stretches over 93 billion light-years from one end to another. So finding a planet so close and so promising for scientific exploration is like finding a gem in a pile the size of Mount Everest, a gem that potentially holds mysteries about existence itself. In the grand tapestry of the universe, Proxima B is a complex thread offering us significant hints that could redefine how we comprehend life. And habitability. It's not just Proxima B's nearness to Earth that excites researchers, but also the captivating signs that this planet isn't just Earth-like. It may be Earth 2.0.proximab, sits comfortably in what space specialists call the habitable zone of its parent star, where conditions are neither too hot nor too cold, but just right for liquid water to exist. Imagine waterfalls, meandering streams, vast lakes, and perhaps oceans as deep and mysterious as the Mariana Trench. But before we begin dreaming about visiting Proxima B, we should consider a couple of its peculiarities. For example, a single day on this entrancing exoplanet lasts a staggering 11 Earth days. Imagine sunrises that not only introduce a new day, but unfurl slowly, resisting the arrival of afternoon. And sunsets that linger, creating bright hours that photographers long for. While it sounds idyllic, it also has important repercussions for climate and habitability. How would humans adapt to biorhythms on Proxima B? Would we really require 3 or 4 meals in a single day on that planet? Would we sleep the same way on this very strange world? The basic patterns of life as we know them would be simultaneously intriguingly familiar and frustratingly peculiar. It's as though nature is giving us a riddle wrapped in another. Riddle testing our understanding of what makes a planet livable. You may wonder how we can gather accurate, and reliable data about a world we've never visited. The James Webb Space Telescope delivers all its capabilities like a giant Swiss Army knife. It's more than just a telescope. It's a complex research lab in the vacuum of space. Thanks to its innovative technology, cosmologists not only observe planets, but also examine them through a scientific lens using instruments that would make CSI labs look basic. Using advanced spectrographs, the Webb telescope can analyze the light emitted and reflected by these distant planets. Each element or compound in a planet's atmosphere either absorbs or releases light at a specific frequency. By focusing on these patterns, scientists can perform a remote biopsy of celestial bodies, determining not only atmospheric pressure and density, but also the possible presence of compounds essential for lifelike organic carbon, water molecules, and even oxygen. Space legal science is not just cosmology's space criminal science. We don't sit idly waiting for clues to come to us. We actively seek them, exploring the atoms and molecules that make up these complex worlds. The Webb telescope isn't just an eye in the sky. In the sky, it's an extremely specialized research lab, investigator, and cosmic detective all in one. It allows us to turn our hypotheses and theories about alien worlds into testable methods to confirm or deny them, changing our understanding of what might exist beyond our blue dot. Right when you thought you had uncovered the most stunning layers of this galactic onion, the story takes an unexpected turn, just like in any science fiction thriller. Scientists using the James Webb Space Telescope received something surprising from Proxima B, a signal so astounding that it spread throughout academic halls and social media, named as a possible technological signature. It was an electromagnetic discharge so complex and so well structured that it could indicate the presence of an advanced civilization. The collective heartbeat of humanity seemed to stop at the peak of a discovery that promised to reshape our our view of reality. Could the signal be the actual proof that we are not alone in the universe? And precisely. Quickly as it appeared, the signal disappeared without repeating, leaving behind not just a stunning silence, but also a maze of unanswered questions and bubbling hypotheses. Was it simply a transient cosmic anomaly, a random event of infinite arrangement, or something else, intentional, a coded message, or even a sign of extraterrestrial intelligence? The solitary mission cast a sad remnant of mystery over Proxima B, sparking wild discussion and speculation. Was it just a passing oddity, or does it belong to a much bigger story, more perplexing than we can imagine? But wait, The tale of our cosmic exploration is far from over. The ink has not yet dried, and new chapters are still being written. This time, it's not just conventional specialists, but Harvard researchers who are leading a shift in perspective. As we move forward with the search for extraterrestrial life, they are not satisfied with just studying the signals and anomalies we've discussed so far. They're upping the ante by turning the James Webb Space Telescope into a kind of giant night vision telescope. They plan to search for artificial light sources in both the dark and illuminated areas of distant worlds. We're looking at staggering possibilities, such as the chance of detecting artificial versions of cities glowing in the dark, like brilliant SPS. Imagine seeing the glowing light emissions. It could be a city humming with the presence of an advanced human civilization transmitting its glow into the vast oceans of space as we continue to unravel the secrets of the universe. The quest for extraterrestrial life takes on new aspects. Beyond the immediate interest in Proxima B, our grand pursuit digs deeper into the vast new regions of space. This pursuit is driven by both technological advancements and a significant desire to understand our place in the universe. Advances in cosmology and space exploration have led to the discovery of various exoplanets with potential habitability. Instruments like the James Webb Space Telescope, biosignatures, and ground-based observatories have expanded our ability to detect and study these distant worlds. One particularly fascinating area of study is the search for biosignature signs of life. These signs could include atmospheric gases like methane or carbon dioxide, which, under the right circumstances, could suggest biological processes. The JWST's capabilities extend beyond basic discovery. Its advanced instruments can measure the atmospheric composition of exoplanets, helping scientists pinpoint potentially habitable worlds. The data collected by the intricate processes seen through the telescope can unravel new insights about the environments of distant exoplanets. With our exploration efforts continuously advancing, Proxima B remains a key subject of inquiry, guiding us into the future of space exploration and the discovery of extraterrestrial life. As the James Webb Space Telescope expands our understanding of distant planets, the pursuit of life beyond Earth has become a central focus of scientific inquiry. The technology and methods we're using to examine these exoplanets, such as measuring their atmospheric composition, can provide the most direct evidence yet of whether they could maintain this level of existence. The quest isn't just about searching for familiar Earth-like environments, but also considering the vast diversity of conditions that may allow life to emerge in unexpected forms. The idea of discovering extraterrestrial life, or even just signs of life, carries profound implications for humanity. It challenges our view of ourselves as unique in the universe, expanding our understanding of life's possibilities. Imagine discovering that life has evolved elsewhere, in conditions very different from those on Earth. Could life on other planets have adapted to extreme temperatures, toxic atmospheres, or a lack of water? Could it survive in environments we once thought inhospitable? These questions push the boundaries of biology, philosophy, and cosmology. Proxima B, with its potential for habitability, serves as a beacon in this quest. Though its conditions may differ from Earth's, it represents a prime candidate for study. Even if life doesn't exist on Proxima B, the very possibility of habitability opens doors to exploring other star systems that could harbor life. As we continue to gather data from this distant exoplanet, we are also learning about the broader universe, refining our tools and techniques to detect life across the cosmos. One of the most exciting prospects is the possibility of locating biosignatures or technological signatures, indicators that life might be present, or that an advanced civilization might exist. While scientists are still cautious about drawing conclusions from anomalous signals like the one from Proxima B, the search for artificial light or other technological signs could revolutionize the way we think about extraterrestrial intelligence. The idea that we might be able to locate cities or infrastructure on distant planets opens up new avenues of inquiry. blending astronomy with the search for civilizations beyond our own. This dynamic, ever-evolving exploration is driven by collaboration across many fields like biology, astronomy, engineering, and artificial intelligence. As technology continues to improve, our ability to scan the cosmos with ever greater precision will only increase. Already, new missions are being planned to take advantage of the Webb telescope's capabilities, with upcoming projects aimed at investigating even more distant exoplanets and star systems. What does all of this mean for the future of space exploration? As we expand our reach into the universe, we're faced with an exciting possibility: the exploration of a cosmic ecosystem interconnected and teeming with potential for life. Each new discovery, whether it's the atmosphere of a distant planet or a peculiar signal from a star system, brings us one step closer to understanding our place in the vast cosmos. But with every answer, new questions arise, questions that challenge our deepest assumptions about life, the universe, and everything in between. The search for life elsewhere is not only about finding something familiar on Earth, it's about embracing the unknown, pushing the limits of our imagination, and acknowledging that we are part of a much larger, enigmatic universe. The future of space exploration is unfolding before us, and it is filled to the brim with opportunities to rethink everything we know about life, existence, and the cosmos. As we move forward, the discovery of another Earth or signals from an alien civilization may not be just the end of one chapter.